Right, let's move on to exercise 3 now. Right, for formatted I/O practice exercises. Let's just copy this as well into a C program. Best way to see what's going to happen. And as long as my mouse decides to behave, here we go. All right, so let's make a new code blocks file. File, new file. All right, C file. And we're going to call this exercise 3. So I just copy pasted the problem statement in there. We're going to use scanf, so we need standard io.h. We need to include that. Need my return 0 statement. All right, I have a working C program that will at least return a value of 0. We want to do more than that. So we say, suppose that we call scanf as follows. Right? So we're going to need this scanf statement in here. All right. And it won't copy those double quotes very well. We've got this. All right. What will be the values of I, x, and j after the call? Assume that I and j are int variables and that x is a float. Let's move that comment down here so we can read it a little easier. So assume that I and j are x are int variables. That means in my C program, let's declare I and j, and x is a float. Let's declare x. So remember, when we declare a variable, it has to have a data type, and then we give it its name. All right, let's take a look at the scanf. So we've got 3 specifiers here in the format string. So this area here that's in double quotes we refer to as a format string. %d says to read the first item the user enters as an integer. So it's looking for, it's going to try and match a pattern as an integer, right, a base 10 integer. And then it says try to read a floating point number after that, and then try to read another integer after that. All right, well, let's look at this first %d. Right, when it reads the integer, it's going to store this i's address. So I is declared as an int. That's why we're going to use a %d here with the I. And remember, with scanf, we always have to use this operator, the ampersand, that says the address of I. When we use printf, we don't have to use that address operator, but with scanf we do. Right, the next thing, when it tries to read the float, we want it to store an x, so we say store it at the address of x. All right, and then the last integer it reads, %d, says to go ahead and read that and store it at the address of j. Okay, so we're saying, what happens if the user enters 10.3, 5, and then 6? Well, there's going to be a pattern matching scheme here. In terms of, if the first thing we're looking for is, let me put this down here in comments. The first thing we're looking for is an integer. So what's going to happen is you have to remember that all of this is going to go into a buffer. The user is going to type a 1, a 0, a period, a 3, a space, a 5, a space, a 6, and then hit the enter key. So all of that is stored out in memory. So it's going to go into that input memory buffer, and it's going to say I'm looking for an integer. And this first digit 1, oh, well, that meets my requirements. That's an integer. Basically, it's going to be able to read the 1, 0 and say, yeah, I recognize that as an integer. When it tries to read this period, it's going to say, nope, that's not an integer, so I'm going to stop. And what it's going to do is it's going to extract the 1, 0 from the string and store that in I. Then it's going to come back and look for a floating point number. So it's going to start, it didn't extract the period. So it's sitting there in the buffer now, and it's looking at this period. It's going to say, well, I want a floating point number. Can a floating point number have a decimal point in it? Yes. Can it start with a decimal point? Yes, it can. So it's going to say, oh, well, 0.3, right? That looks good. When it gets to the space, right, a space isn't part of a number, so it's going to stop there. And what it's going to extract from the string is the 0.3, we'll see that x has the value of 0.3 stored in it. So now when it's done, remember it was sitting there in the stream. And anytime you try to read information, it's going to skip over leading white space. Remember, a blank space is white space. So it's going to skip over that. So basically, it reads it and throws it away. And then it says, oh, there's a 5. Well, I'm looking for an integer. Could a 5 be part of an integer number? Yes, it can. So it reads that, and then it looks at the next character. And the next character is white space, and that says, okay, I'm going to stop reading because that's not a space, isn't part of an integer. So it's going to store the number 5 inside the letter, or inside the variable j, and then still sitting out on the string is the space character and the 6. It's still sitting out there. That information is not being used by our program. The thing with scanf is you have to get used to its pattern matching scheme. So let's see if this is the case. Now, if I don't do anything with this information, so I actually have to go ahead and remember to remove exercise 2 from the project. I'm just going to say build clean here, clean up the whole build environment. And if I say compile, that compiles just fine. If I say build and run, right, well, this screen pops up. We don't know what we're supposed to do, but except the exercise says type 10.3 space 5 space 6, hit the enter key. And of course, it doesn't show us what was stored in those variables the way we've written the program. Now, let's see. I'm going to put the cursor here, and I'm going to use the debugger. I'm going to then right click, and I'm going to say run to cursor. And so what this did is this popped open a window here for me. And I don't like that it doesn't populate the variables automatically. I want to watch I want to watch J, and I want to watch X. All right, so back to my console screen here. Code blocks console screen. So 10.3 space 5 space 6, hit the enter key. All right, so you can see now, and what run to cursor did is run to cursor actually ran all of the code. It said run everything up until the cursor. All right, so it declared these variables out in memory, and it ran the scanf statement. It read in the information I typed, and then it's sitting here waiting to finish. The program hasn't finished. You can see now out in memory, so locals. These variables were declared inside main, right? Main starts here, ends here. So these variables were declared inside this function. We say they're local to main or local to this area of memory. That's why they show up under locals. All right, notice I has 5, or I has 10, J has 5, X has 0.3. Because floating point has some inaccuracies, notice it's showing way out here 0.12. But it's got the 0.3 that we expected. Don't worry about this. This is related to the way that floating point information is stored in the computer. Right. So with our scanf pattern matching, right, we can see in memory that what we said would happen actually did happen. And I could either say go ahead and finish. In this case, I could say stop debugging. I just like to see what's in memory. Now, if you want, you could go ahead and print that information if you weren't using the debugger, but I encourage you to start learning how to use the debugger. And if we wanted to just say, oh, well, let's show what's in I, let's show what's in X, which is a float, let's show what's in J, %D, that's an int, and I, X, J. And build and run. And now I'm going to type my 10.3 space 5 space 6, hit the enter key. All right, so I has 10, X has 0.3. Notice that 0.12 isn't popping up, right? That weird value it rounded it to on the end, do the inaccuracy. And there's J is 5. 6 is still sitting out on the screen. It had not been extracted. As a matter of fact, well, we'll talk later about how to remove other items from the stream. We haven't learned loops. If we wanted to, we could ask it to read the other characters out on the stream. We'll learn how to do that later. So let's just stick with the pattern matching right now for exercise 3. And that was the whole point of exercise 3.